Welcome to another tutorial of the thermal system design class. Today we're gonna go into the setup and we're gonna start looking on the interface of Ansys Fluent in order to make simulations. So first of all, the geometry that we're using right now is very similar to the 2D geometry that we already created. The only difference here is that our cylinder is not at the center of the domain. This is just because sometimes it's a small trick that we use for us to at the very beginning of the inlet we'll let the flow fully develop after coming in contact with the cylinder wall in this case. So this is a trick that you can often use. At the end of the day, the domain it can be as large as you want in length and on height. So some of the dimensions, we have a cylinder in the middle. It's a 5-inch cylinder. We have a height. The height is 40 inches, I'm sorry. The length is 150 inches, and this cylinder is 50 inches away from the inlet of the domain, and is at the very middle of the height. So that's our simple geometry. We're making a surface body. We use the Boolean feature in Ansys. So if we close this and we take a look into the mesh, so this will be our mesh. This is how it looks. So we use the inflation that we learned from last tutorial, I'm sorry. So you can see that we have 5 layers of inflation right here, 5 layers. And we have selected our different name selections. So we name this side to be the inlet, the other side is the outlet. Our walls are our symmetry. If you remember from last tutorial, if we just select a simple wall, it's gonna have viscous effect on the wall. But if we select the symmetry, it's not gonna have the viscous flow. So that's why we selected symmetry. And we also have our cylinder wall. So if we close the meshing, notice that right here in the geometry, I set up my problem already as a 2D analysis. We'll take a look into that a little bit later as well. So if we go to setup, we can see here on our right on the schematic, on general, we have different things. We have the precision. So it's basically asking us if we want single precision and double precision. For those of you that have taken a course in numerical analysis, you know that double precision is basically how much your computer, single or double precision is how much bits your computer is taking in order to solve your problem. So double precision is always the best way to go. Sometimes we can use single precision. We can use single precision as problems are less complicated. In this case, we're gonna use double precision. I'm not gonna click it just yet. I'll show you why in a minute. We have the show launcher startup. Displays the mesh after it reads it, either if you want it or you don't. Also, we have this use workbench color scheme. So if you deselect this when you open your Ansys Fluent, you'll see that the background of the graphics is gonna be black. So sometimes it's better to look into the solutions when you have a black background, especially looking at the contours. This is a matter of preference. I rather have it the normal color of Ansys. So this is on this side. So let's click on setup. The first time that we launch the Fluent setup, it's gonna give us these options. So notice that right here we can again click on double precisions instead of clicking on the other side, on the right side. And it also gives us the option to set up this as a 2D or a 3D problem. I already solved it. I already selected the 2D, so that's why it's locked on here. But if in the case that it gives you the option, in this case, because you're performing a simulation on a plane, you will select the 2D. The solver processes, the GPG, the GD, and the GPUs per machine. You have all that information here. So let's start it up. So once you open Ansys Fluent, this is what you will get. So you will get, this is the graphics window, and on your right side, you have your graphics window and your text window. So this is important. This is gonna tell you whether, for example, here is reading the different things that we already incorporated into our model. It's reading the inlet, the outlet, and we can see that it's already shown right here. We have different in here on the graphic window. It's where we're gonna see our plots, our contours, and the different solutions that we program Ansys to do. So this is the model. We can see that it's fully imported from the meshing. Right here in the left side of these graphic windows, we can see different options. So it's gonna give us the option to just select somewhere on the body. We have the option to pan. Let's select this. We have the option to zoom in or zoom out. Zoom to a specific area. Notice how this wall, it has like it's selected in blue. So that's indicating that it is the inlet, and this one is selected as red, notifying you that this is the outlet. So also you can see that the walls right here, it's very noticeable. So we'll use one of our features. We can see that it has like a yellow line that's indicating that this is a wall, more specifically a symmetry wall. And if we close here, we can see a white line. So this is indicating that is the cylinder or just a normal wall. So you can play with it just to see the different things that it offers here on Ansys Fluent. We'll go, if we click into General, we can see that we have these options already on the left side. We have the outline view, and here it says the task page. So let's see the different things that we have. For example, we can see the scale. So we have different options to scale our model, and we can also convert the units. MECH was created in, it's asking us if we did it on inches, on meters. View the length in meters in this case. That's how we have it. We can also see check. So if we click on check, we can see here in our text window that it gave us some information. So it's telling us that domain extents. It's telling us that the x coordinate, the minimum that it went, and the maximum. We also see the volume statistics. So if we see here, if our minimum volume is a negative number, most likely our solution is not gonna converge. So definitely it's important to click on check to see if everything is proper to run a simulation. We can see the face area statistics, and it checked the mesh. Let's click also on report quality. So here it's reporting the mesh quality. So it's telling us, so a good mesh, typically the orthogonal quality is in between 0 to 1. So the closer it is to 0, the worse it is, and the closer it is to 1, the better. So it's telling us right here that the minimum orthogonal quality is 1.79, basically 0.179. So it's not a very good meshing quality at the moment. It also gives us some advices on how to improve the meshing. And it also gives us the maximum aspect ratio. So we can click here on display. So if we click on display, it's going to give us the different options, the name selections that we gave. So if we deselect it and we display it, it's erasing our body. So if we just want to look on the cylinder wall, we can see that it appeared there. If we just want to see the interior surface body, the inlet, the outlet, the symmetry. Let's take away the, you can see that there's different options of display. We just want to see all for now. Also, we can go into units. We can give units to the different things that we have, different simulations that we're going to perform. So that's basically the things that we have. Something interesting also is that we can create new surfaces. We'll learn this as we go. We can outline interior, exterior. We can select colors, so we can change. For example, if we don't want our inlet to be light blue, I don't know. Let's make it. If you want it to be dark blue, for example, we'll set the colors. It's gonna give you that color, dark blue. Close. So you can mess with it. Also here in general, we can see our solver. So it's giving you several options. So we have type. So we have two different types of simulations, pressure-based and density-based. So basically, if the density is not constant on your simulation, you will want to go into density-based. Most of the time, we're gonna go more into a pressure-based. The velocity formulations. So for example, if your body is static, we'll want to have an absolute. If we have a more dynamic problem, we'll maybe want to go into relative. The time, we have steady, which is just a steady state, and basically the body is not moving and time is not dependent on the solution. We have transient, we have different either changes of loads, changes of velocity, or anything. We'll want to go into more into transient. And we also have the 2D space. We can have a planar analysis like we have it right now. Sometimes we just want to, so we have the same problem. So we have a symmetric problem where we have the same thing from the left side or the right side. So if you do that, we can save some computer space, and we can just calculate one side and the other side is going to be exactly the same because they're symmetric. So we'll want to go into the axis of symmetric. If we have a velocity that swirls, we'll maybe want to go into that one. And at the very end, we also have gravity. So if we select gravity, it's gonna give us, in this case, it's not giving us the z-axis because we don't have this is a 2D problem. But let's say, for example, that if we want to set up some gravity, if we just leave it like that, because our interface or our model or Ansys doesn't understand that gravity always goes from the top, and if we leave it as a positive, it's gonna say that the gravity is going upwards. So make sure that you know this and you select this to be negative, in negative 9.81, for example, in this case. But let's deselect that for now. So we have different things. We can evaluate the mesh quality. We can improve the mesh quality. We evaluate the mesh quality is gonna give us the same thing as we did when we checked. And we have the zones, we have the interfaces, the mesh models, and we'll be looking more into this interface in future tutorials.